This video is just to go through and do another example of evaluating an improper integral. Uh, and so here I've got one where both my bounds are infinite, so I do need to split this up into two integrals. And again, I'll just have them joined using the additivity property at 0 for a bound. So I'll have the integral from negative infinity to 0 of 1 over 1 plus x squared with respect to x, plus the integral from 0 to positive infinity of 1 over 1 plus x squared with respect to x. And I can then rewrite this and replace my infinite bounds with dummy variables and do limits on those. So I'll use a for this dummy variable to replace the negative infinity. And I'll use b to replace the positive infinity. And so what I now have here is I now have definite integral. Fortunately, it's going to be, since it's the same integrand, my antiderivatives are the same for both. So the limit as a approaches negative infinity of, and the antiderivative is the inverse tangent of x from a to 0. Then I'll have the limit as b approaches positive infinity. Same antiderivative, inverse tangent of x, but this will be from 0 to b. So now I can plug in my upper and lower bounds to each of these antiderivatives. And I'll have the inverse tangent of 0 minus the inverse tangent of a. And then moving to my limit as b approaches positive infinity, will be the inverse tangent of b minus the inverse tangent of 0. Well, the inverse tangent of 0 is 0. So those are taken care of. I now have the limit as a approaches negative infinity of the negative inverse tangent of a, plus the limit as b approaches positive infinity of the inverse tangent of b. Now, to evaluate these, it helps to remember what the graph of inverse tangent looks like, where, remember, it's negative pi over 2 here. What I get is this shape. But remember, this is the inverse of tangent. Regular tangent has vertical asymptotes when x is positive pi over 2 and negative pi over 2. Inverse tangent then has horizontal asymptotes at those y values. So as x is approaching positive infinity, like with my b, my inverse tangent is approaching a y value of positive pi over 2. So I'm going to have a plus pi over 2 here. As my x's go towards negative infinity, the y values are approaching negative pi over 2. I'm doing the negative of that, so the negative of negative pi over 2 is positive pi over 2. And so I get that this integral from negative infinity to infinity, 1 over 1 plus x squared with respect to x, is going to equal pi over 2 plus pi over 2, which is pi. Now, one thing I forgot to mention in the first video is these are limits that we're doing. And because my x's, or my bounds are infinite, I never actually reach these values, but I approach them. And so what we say is that this improper integral converges to pi. So we refer, instead of saying an improper integral equals, when we say it, we say an improper integral converges.